Hello everyone. I'm really happy to have everyone here. It's really nice for us to be talking about the topic that we are going to discuss today, which is event-driven architecture. This is a content that we from the education team have worked hard to propose, to create. And the intent here is that we promote more knowledge, making it possible for every developer, functional analyst. It doesn't depend on the role you work with, but we want to bring to you more knowledge so you can make more performatic integrations, so we can make a better use of our platform, which is very, very powerful. And we want to make this content available to you so you can all achieve that and we can make the best with the tool that we have here, which is DGB Integration Platform. So it's really nice for us to have you all here. And I'm going to present the agenda, the topics we are going to discuss now. We will start introducing a use case. So the whole content that we proposed here is based on a use case that is very familiar for every developer here, functional analysts, or CSMs. It's something that we have seen a lot. And we want to present problems and solutions based on this day-to-day use. So we are going to start introducing the use case of a fictional developer, but the reality is that it's not so fictional. I think that many of you is going to identify with her and with the use case. So that's the first step. After that, we are going to review the pipeline that she created. So we are going to see the first version of the pipeline, which was a tightly coupled version. We are going to see its problems and how we can fix them, how this developer from our use case, the solutions she proposed in order to fix the integration, to get better results, better solutions. After that, I'm going to pass the words to Danilo, and he's going to present event-driven architecture. So we are going to dive on that topic. We are going to present what it is in details, and the last part of it is going to be adapting the first version of the integration into an event-driven architecture version. So that's it. But before we start, I would like to introduce myself and introduce Danilo, since many of you here haven't spoken with us before. So my name is Ron, and my colleague here is Danilo. We are from the education team. We are instructional developers, which may seem a little bit new term for some of you. We are a mix between a developer who creates solutions, who develops integrations, but we also are instructors on the way that we mean that we produce content, we bring more knowledge, so we can make as many be able to make the best with the platform we have. So that's the intent of our job and of this webinar as well. So let's start talking about the use case that we are going to present. So here we have Clara. Clara is a developer, a very talented one, by the way, and she was hired for a data processing project by a healthcare company. So she needed to be part of a project in which the final objective, the final goal was they wanted to reduce costs associated with paying fake invoices. So this healthcare company was having a lot of trouble and was wasting a lot of money paying fake invoices that were arriving to them. So the solution here proposed was, we are going to use an artificial intelligence service, and this service is going to help us recognize the validity of those invoices. Then the integration can decide which they are valid or not, and pay only the valid ones. So that's the whole point. But in order to do that, we have to create an integration with many steps. And that's where we enter. That's where DGB enters and makes the magic that we all know. So how is this integration going to start? First of all, we have a database. On this database is where we have a list of invoices that have to be verified. So we have this database, and our platform is going to query the database as the first step of the integration. So we query the database, we get a list of pending invoices that need to be verified, and based on that list, we can now see the invoices that we have to verify, and then we download them as PDF from a storage service, and then the last step is we send them to the artificial intelligence, and it's going to process it and return some information, some probability, and then DGB, the integration platform, can calculate and update the status of these invoices as approved or not approved, and then we can make sure that the final objective is done. So this is the whole flow of the integration. Of course, we are going to open the platform in a few minutes, and I'm going to show you the first version that Clara developed, and then you will see step by step of this flow right here. But if you get to understand what I think that you guys have already understood, if you get to understand the scenario here, this is the whole flux. This is how it's going to work. And then based on the return from the AI service, we are going to decide if it is or not a valid invoice. That's the whole point of the integration. So up to now, guys, I want this to be in two ways. You say as well when you have doubts, when you have questions. So please feel free to ask. Until now, does anyone have a question? All good? Nice. That's great. Thanks for the feedback, guys. So let's move forward. All right, so initially Clara developed her integration. It started working, all good. She created everything on one single pipeline, which was working initially, but as soon as it went to production, she started to see that the volume of data that was processed was much higher than the pipeline capacity. So that was the first problem. She saw that they were having timeouts, they were having out of memory, and the volume of data that was being processed at a time was more than the pipeline could process. Even though she tried to scale to a larger pipeline, it wouldn't work because the volume was increasing time after time. So she had to find her first solution, which was pagination. She went to DGB Academy, she went to DGB's documentation, she studied, she saw that if she could start processing data in batches, maybe she would solve her problem. So that was the first approach that she took, and it was effective. She got the benefits from pagination, and she started processing data not in one single block as she was doing before, but now she started processing the data on batches. So with these batches, the performance was better, but still she couldn't solve the problem. Even though she paginated, it was working, she got out of most of the problems of timeout, there was a problem that she couldn't fix. First, the number of invoices were increasing on the database on a faster pace than the number of processes that were being processed by DGB platform. So it doesn't matter that it was working, that it was, how do I say, it was being processed as she wanted. She didn't have any timeouts, but the queue started to grow, and she needed to make it stop growing so fast. So she needed to implement a kind of solution that would make it possible to process more data more quickly. That's when she decided to search for another improvement, and this improvement was event-driven architecture. But how did she find out about event-driven architecture? First, she needed to improve the pagination, improve the integration. So she talked to architects, to other developers. She went again to DGB Academy, and she found out that creating and decoupled kind of architecture, she would be able to process more data. So that was the first point. She found out that she had to change the architecture of the integration. She had to think of a better approach. And additionally, as in the beginning, she had a limited number of licenses that the customer provided her. Now she had to get more licenses. And we know that sometimes she had to advocate for more licenses. We have to prove to the customer that if we use more licenses, we are making a more profitable choice. So that was the point. She advocated, saying that if she spent more licenses, but at the same time, she increased the capacity of processing, she was going to bring more profit for the company. She was going to bring more benefits for the company. And that's what she did. So that was the first part of the presentation. We now have what Clara did initially, and we are stopped on the part of her story where she finds out that she needs to implement event-driven architecture to her pipeline. But before she moves to that, before Danilo presents it to you, I want to just show you the first version of the pipeline that she created. So we have a scheduler here, a scheduler trigger, not a big deal of a pipeline, a really simple one. We have a query to the database, which was the first part of it. We verify if we have records to process or not. And if we have records to process, then we can do that on the on process of this for each component right here. So we have the whole steps here. I don't have to dive in too much on this. That's not the focus. But as we saw, the flow is very clear, easy to understand. We update the integration status of that record. We download the invoice. We send it to the AI service. We get an output. And based on the output, we decide if this invoice was valid or not. And then this last part here of the integration is the one responsible for creating an execution summary. So this is it. This is the whole pipeline here. And I guess that if any of you guys have paid attention, many of you have already found out one simple improvement that we could make to this coupled architecture version, which is using a StreamDB instead of a DB with for each. We know that the combination with DB and for each may not be the best choice, and it's not so performatic because when we use these components together, first we need to wait for this one to finish its execution, and then we start processing the data. If we make a choice of using StreamDB, we are already able to start processing the data as it is being retrieved. So which is, it is a much better process. I'm going to make this adaptation here to help Clara improve the first version of the pipeline. I'm going to use the StreamDB right here. I'm going to pass the parameters that we were using before. I'm going to copy the global. I'm going to copy the query. Let's set it here. So first, let's put the global. Let's put the query here. Just one quick thing, guys. We were talking that we were saying that she used pagination first to start solving the first version of the problem, let's say it. And how did she start using pagination here? She made a really simple approach, which was using limit on the SQL query. Just by doing this, as she is consulting a list that has a pending status, just by using a simple limit, she could use pagination. She restricted the number of registers that she wanted to work with at each time, according to the limit set here. Of course, we have many other kinds of pagination that we can implement, more complex ones, but for the time, that did very well. So this is the part of the StreamDB. Now, all the logic that we have here on the on process of the for each, we are going to copy it. Sorry, let's copy it all. We are going to move it to the on process of the StreamDB. Let's rearrange. Now we can cut this off, as we are not going to use it to process the data. Instead, we are going to use the StreamDB. And there we go. Just a warning here. It is saying for us that we need to use at least one component on non-exception. So let's do that. I'm going to use a log here. Of course, if we were dealing with a real world development, we would use more than a log here. We would make a better error treatment. But for now, that will do. And just one quick fix. Here, we were verifying if we have the registers to be processed using row count. We verify that row count is bigger than 0 because the DB component returns a row count on the output. So if it is bigger than 0, it's because the query returned at least one register. Let me show it to you. Just quickly demonstrate. So there we go. Row count, if we have a register to process, this would be bigger than 0. But now, as we are using StreamDB, the output of StreamDB is a little bit different. We have a execution summary, which gives us total, success, and failed. So we are going to use total instead of row count to make sure that we follow the right path when we have registers to be processed. So let's change this to total greater than 0. And the other one is just a otherwise. So we just need to change the name. All right, and there we go. There we have our integration. It's on its first version, but it's already better because we are using StreamDB instead of a DB connector with a for each. And here's the first part of the presentation. And we are open for another Q&A if you guys have any questions before I pass the word to Danilo, and he's going to go there with the event-driven part of it. All good, guys? Does anyone have a question? I want you all to feel free to ask it. So that's great. Danny, you go there, man. Thanks, everyone.
Thank you so much, João. Awesome explanation. Hey, guys. Thanks for being here. Thanks for paying attention. Now I'm going to present you how Clara asked for information, how Clara went to GHB Academy to understand how she could improve her integration, okay? So let me present my screen. And I will do a little bit summary of what was presented. And for do that, I have a Miro here to show you what she did. So what was the problem of the integration of Clara? In a couplet version pipeline, that is one pipeline doing all the things that was carrying the database and then processing each database inside of the same execution and then receiving the response of AI service and then updating the database to approve it or disapprove it in voice. So then we have a problem here. And what is that problem? Since a pipeline has a limit of 15 minutes execution, if we retrieve some records at the same time, it should be a timeout. So let's do some calculations. 15 minutes times 60 seconds equals 900 seconds, okay? So if each execution, if each processing takes maybe 2 seconds to transform the invoice in pending to approve it or disapprove it, that is really fast, to be honest. It should be maximum of 450 records in the same execution. So we have that limit. If we are retrieving that information and for some reason the database returns 1,000 of invoices, 10,000 of invoices, that pipeline should break in a timeout problem. So, and she understood, analyzing the design of the integration, that the problem was the string DB or the for each was multiplying the number of data retrieved and the processing time of each record. So for example, if you have 450 records retrieved from database and each one takes 2 seconds to be processed, we have a timeout. So that was the problem. That multiplying thing here is the problem. What if the records takes more than 2 seconds? We are dealing with external servers. We are dealing with downloading a PDF in external servers and then sending to AI servers and waiting for their response. So what if the records takes more than 2 seconds? So the max of records of each execution should be even lower because of that. So that's why she implemented pagination, because we need to guarantee that all the times we retrieve the database, we have a controlled quantity of records being processed in the same execution. And it should solve the problem of timeout and maybe out of memory. But the problem is, what if the database deliver more than 450 invoices every 5 minutes? So 1,000 at minute, 10,000, it's not scalable. That's the other problem she noted by analyzing her integration. So she decided to ask for developers, ask help for developers, architects, and do the DGB Academy courses. And she did the Event-Driven Architecture 1 course in DGB Academy and understood that the pipelines can communicate with each other, can send information to other pipelines by using event-driven architecture. So a little bit of explanation of how the DGB do this. DGB have an event broker, and we can publish messages, we can publish events using pipelines by using a component called event publisher. So for example, if we have a pipeline that is doing some processing, I don't matter what it's doing, but it needs to publish an event and carry a message. So it's publishing an event. That event will be sent to event broker of the platform. That is a RabbitMQ, and then it will be queued. So the event broker will listen all the events being published of all pipelines and queue all that information. And after this, it will be sent to every subscriber that is listening to that specific event. So for example, we can have different type of events here. It could be green, it could be red, blue, that represents different events being published. And for each one, the event broker will understand what pipeline is listening to each event and then trigger that pipeline. And we do this using the event trigger. So a good thing about the event-driven architecture is we are going to decouple all the information, and creating pipelines with single responsibilities is better than coupled versions. Because for example, if something went wrong here, I don't know why, for example, an API service is not working anymore, or the database is not working, or we do a lot of stuff in the same pipeline and then something is not working anymore, the whole integration will stop. So maybe we are going to receive some problems and some messages talking about those problems, because everything is in the same execution. So one problem could stop all the execution that carries 100 of records being processed. And by decoupling it, by using a pipeline to just retrieve data and using a pipeline to just process that data, we can make that decoupled version that if something went wrong in a pipeline, the other is still working without any problems. That is about separating the things, the responsibilities in the pipeline, okay? And another good thing about event-driven architecture is, let's imagine that the record that is being processed of the invoice needs to be used for another reason. Okay, so we have a pipeline that is processing, sending to AI servers, but we can have another processing that is, for example, taking that ID and sending to a BI service or anything like that, another processing. Okay, it's a different thing. We can just create another pipeline and make that pipeline an event listener that it's listening to the same event. And we don't need to change anything that was already built. So for example, in the previous case, if I want to improve that integration, add some processing, I needed to go to the pipeline and change and stop it and change something and then publish it again. And by doing a decoupled version, I just need to create another pipeline that listens to the same event without changing anything else that's already working, okay? That's a good thing about event-driven architecture. So now we understand how it's work. Let's see how Clara used it to improve her integration. So instead of processing everything inside of the loop, inside of string_db or the for each, I could just publish an event for each record, okay? So instead of multiplying the number of the records with the time of the processing of each event, so in the previous case was, for example, 400 multiplied by 2 seconds or anything like that. Now I'm multiplying by the time of publishing an event that is milliseconds, not seconds anymore. It's 100 times faster. So I don't need to deal with the problem of timeout here anymore, because it's a lot faster than just processing it here. And in the second pipeline, we still have the same time, 2 seconds, 10 seconds, or 50 minutes if you want to process a single record. So we are using all the power of a pipeline, all the resources of the memory RAM, of the CPU usage for a single record, and we guarantee that timeout or out of memory problems will not appear anymore. And if it appear, for example, out of memory because we are downloading an invoice, we could just scale it up for using more resources. For example, we can use a small pipeline here and scale up for a medium or a large pipeline, and we are going to see it later. So let's come back to the presentation. We saw that Clara has implemented pagination, and in the decoupled version using event-driven architecture, she can do it too. So even if the publishing event is 100 times faster, we can control the carry of the database because it's important to be to build a resilient pipeline. Okay, we need to have control of the quantity we are retrieving, and pagination will help us in this case. And we saw that she built a first pipeline that was responsible for consulting the database in a paginated manner. It fetched a set number of invoices and published events for each individual invoice. Okay, and now we are going to see that we can use consumers, that is a kind of threads of the pipeline, to start a lot of executions at the same time instead of one of time. And in the second pipeline, that is the pipeline that is the processing, it will download the PDF invoice and then send to AI service. Now it's decoupled, it's downloading, sent to AI, and now the integration is optimized. Okay. Any questions about this? So if we don't have any questions, let me show you the integration that Clara built. So it's 3 pipelines. Let me take everyone here. That's the first pipeline. That is a scheduler. And that scheduler is triggered each minute, once a minute. And we have that page size here that is 30 for now. So we're retrieving 30 records at the same time. If you go to the the configurations of the string to be, we're going to see that we are retrieving only the integration status pending, and then limiting that carry using the page size we set it before. What is the point of that pagination? That is a simple pagination here. For each record that is pending, we are going to publish an event. And in the second pipeline, the moment that that information starts the second pipeline, the integration status will be processing. So we guarantee that we are just retrieving the pending data here, and it's paginated. So it's now we are just retrieving the pending status, so we don't need to care about complex pagination. Okay, inside of this home process, we have just publishing an event. So for each record we retrieve, we are publishing the EVT invoice processing. And in the second pipeline, let's go to that. We have a trigger that is event trigger, and that is listening to EVT invoice processing. It has to be the same name here, okay? So the moment that pipeline is triggered, we are going to update the integration status to processing, and then we can avoid that the first pipeline is retrieving the same information. And then we are going to download the invoice that is a BTF. We're going to see if that PDF was downloaded or not. And if not, we are going to update the status to failed. If it's okay, if it was downloaded, we are going to send to AI servers that will return a response of success or failed. If it failed, again, we are going to set to failed. If it's okay, so we are going to wait that service called GGB again using webhook to send us the information if the invoice was relatable or not, was true or false. The third pipeline, that is the API, that will be the webhook. We're going to receive that information of the AI servers. We're going to make some calculations to identify it's true, or it's false. And then if it's true, we're going to set the status to approve it. And if it's not, so disapprove it. And that is the pipeline, the three pipelines decoupled, each one with a function here, and we can scale up these pipelines if we want to process more data, if we want to process faster. So we just need to scale that pipelines. That is the version that she built. So let's come back to the presentation. And with the successful resolution of previous challenges, we don't have more timeout problems. We don't have out of memory, and we don't have, for example, the database growing faster than the time of the processing of our pipelines. So it's all working. It's all working. But with that great solution that Clara did, the company expressed a desire for even faster invoice verification. So let's imagine that that verification is taking, for example, 30 minutes or 10 minutes for each record, and the healthcare company wants to do that verification in 2 minutes or even faster. And then the company asked to Claris to do this improvement in the integration, and recognizing the importance of improving performance, they granted Claris permission to utilize additional license to upgrade the integration. So we have already the coupled version. Now they want even faster integration, so I need more resources to do this. And then he granted Claris permission to do this. So before showing how to do this, I'm going to show why they want to improve the velocity of the invoices. So imagine that is a simple platform of the healthcare company, and they are seeing the status of each invoice. So it's pending, it's processing, it's failed, approve it, or disapprove it. They need that information because they approve it, they need to pay, and they disapprove it, they will discard, okay? And since the information, since the database is increasing, the pending here will be increasing too, and they are going to see the integration of Claras when the payment status will become processing or failed or approved. So I'm going to reset the database here, and we're going to see all this working, okay? In the integration we did, the scheduler will be triggered each minute, and in each minute, it will retrieve 30 records. And it may take some time, takes 1 minute to start, but we're going to see the integration working. And then now we are seeing it's processing, it's the integration of Clara build. It's approved or disapproved, so we can see it working, okay? That's the vision of the healthcare company. And the point is, see, we have 30 records here, right? That is because we are paginating the database. But it was really fast, right? It was really fast. So why we have to wait 1 minute until the others invoices start to be processing or being approved? So that was the improvement the healthcare asked for Clara. And she could do this in 2 ways: by making the page size even bigger. She could retrieve 100 invoices at the same time. Now, 1 minute after it started again, she could make the page size 100 records at the same time. But we need to understand if doing this, the platform will be able to process all that records. Okay. And if not, we can scale up the pipelines. So since we are seeing that's working, let's come back to the presentation. Let's see how Clara improved the performance of the integration to build more fast, to process more fast the integration. In the first case, she could use vertical scaling to improve the velocity of each invoice processing. What is vertical scaling? The GGB integration platform can publish a pipeline in 3 options, okay? The small one, the medium one, and the large one. What is the difference between that options? The first one uses 20% of a CPU and 64 megabytes of RAM for a pipeline, for a container. And that pipeline can be triggered the most 10 times, 10 executions at the same time. So it's 10 consumers. It means that if I publish 30 records, 10 of that records will be processed at the same time, and we can set it. So we can set to 1 consumer, we can set to 5 consumers or 10 consumers, but 10 is the limit for the small version. The other configuration that is medium and large is just duplicating the previous configuration. So in the medium one, we have 20 consumers and 40% of CPU, 128 megabytes of RAM, and duplicate it for large. And we are going to use that type of scale when we need more resources to process the pipeline. So imagine we are doing a lot of queries in the database. We need to download a big file in the pipeline, so we need more memory to process that information. And we're going to use different options of vertical scale to guarantee the efficiency of the pipeline. But you can imagine she could use the large one to make the integration even faster, to process more data at the same time, since we have 40 consumers. But it's not a good deal, because we are wasting that resources here just to increase the quantity, the executions in each time of the integration. We have a better way to do this, that is horizontal scaling. So let's see about it. Horizontal scaling that was implemented by Clara is about we have more pipelines at the same time. What do I mean? So since a pipeline is kind of container that we can fill the threads there, that is the executions that we can have at the same time. What if I have more pipelines that do the same thing? For example, if I have 5 pipelines of the EVT processing. So we could process 10 customers at the same time, multiply it by 5 pipelines, and then 50 executions at the same time. So that's because that is the motive that the horizontal scale is the better option for the case of Claris integration. So that's how the container works. We have a cluster, and since we have some replicas, we call it replica. For example, we have the container, the pipeline that is the EVT processing, and we are going to use 10 replicas of that pipeline. Each one of them is in the size small that we saw before, that can process 10 records at the same time. Now we can process 10 times 10, and then 100 times, 100 executions at the same time. So we are filling the container, filling the executions, and then we go to another container and another and another. And then we can process all the query of the event broker more faster than using a couplet version pipeline. Okay, so that's how Clari uses the GGB integrations platform to create a huge integration that can scale up even vertically or horizontally. We can process more data, we can process even faster, just improving that things in the platform. And we can just click 3 buttons and we have the integration processing even faster the records. Any question about this? So that's it. By combining both vertical and horizontal scaling techniques, Claris significantly improved the integration's performance. The upgraded infrastructure with more powerful and parallel processing pipelines enable faster verification of invoices, meeting the company's requirement for enhanced speed and efficiency. So we have now all the invoices approved or disapproved. It could be even faster. In 1 minute, we should have, for example, all these invoices processed instead of 5 minutes, instead of 30 minutes that was before. So that's it. That was our presentation about event-driven architecture. But we have just one more thing here. What if the result of the integration, what if we have failed integration here? What if the AI service was not working and then we have a lot of records that was not processed, it's in the processing or failed? What we can do here? The point is, for every invoice that failed in the integration, Clara needs to take that invoice and process it again, maybe manually, because it's in failed status, not in pending, so the pipeline are not retrieving it anymore. And by doing these main things manually, processing each day, she's using her time that she could use for building another integration by just maintaining the pipeline. So that's what we're going to see in the event-driven architecture too. We are going to see how create automatic reprocessing pipelines. So we're going to reprocess everything without need to go into the platform. The platform will understand if something failed and then try to reprocess it again. And if something failed, even in reprocessing pipelines, we could be notified. So for example, if something went wrong, Claris needs to go to the platform in the monitor screen and see if the record was processed or not. But in the event-driven architecture too, we're going to understand how to create a pipeline to send an email or send a Slack or put that information in a BI service to tell us that the integration failed. So it's all automated. So that's it. That's our presentation about event-driven architecture. Do you have any questions about this?
Hi, everyone. Yeah, I have a quick question, Danilo. What happens if you put the scheduler to run even faster. I mean, faster than it actually would take to publish all the events. For example, it takes, I don't know, 10 seconds to publish all the 30 events. What happens if you make it run every 5 seconds?
We did it. So in the first case, it was 5 minutes. In the coupled version, it was just 1 minute. The point is, if you do this, the events will be published in each 5 seconds. So you're going to publish more events. And publishing more events means more events in the event broker, but the pipeline that is processing are retrieving the same quantity at the same time. So you should just improve the queue of the event broker speed, but not the processing event. So you need to scale up both of them. Maybe sending more events and then processing more events at the same time. You need to scale all the things, not just the source of the resources.
So you would be piling up on the event side and not. All right.
And that's a good question, because talking about what is the I forgot that is in the middle here. So that's the event broker, and the pipelines, they have a limit. That is, when you publish an event, that event will be stored in the queue of the event broker for at most 6 hours. So everything that was in the event broker more than 6 hours will be lost. So that's the problem of queuing in the event broker, not processing it at the same speed. So, right?
Right.
Okay. And that's it.
See.
Thank you, guys.
Yay, what an incredible webinar it has been. We covered a lot of ground. Thank you, Danilo and João, for being our facilitators and subject matter experts today. And we hope to see you all for Event-Driven Architecture 2. Goodbye and take care, everyone.
See you.
Thank you.